Our last example, we're going to take a look at analyzing a normal distribution and learning how to use the mean and the standard deviations to answer questions about the data set. So we have 2,000 freshmen taking a biology test and their scores fell on a normal curve. They had a mean of 70 and a standard deviation of 5. So I created the bell curve and I labeled it. I can't remember if I gave you the labels in the notes, but you could throw those on there real quickly. So the mean is in the middle, so I have that 70 right below that highest peak of the bell curve. And with the standard deviation being 5, that's how I got the labels for the other units along the way. So 70 plus that standard deviation plus 2 standard deviations plus 3 standard deviations. And of course subtracting off to the left. Next we're going to answer what percent of scores are between 65 and 75. So when we look at our bell curve, 65 and 75 are both 1 standard deviation away from the mean. So if you remember that first graph that we looked at, 34% of the data falls within 1 standard deviation high or low of the mean. So when we combine those together, like we're doing in our example, we get a total of 68%. Our next question, we're looking at scores between 60 and 75. So now we have to think about the fact that we've got that 68% plus it was a 13.5%. So to get that extra standard deviation away, remember 65 is 1 standard deviation below the mean. 60 is 2 standard deviations below the mean. Again, reminding ourselves of this original bell curve, we're looking at an additional 13.5% plus that 68% we were already looking at. So that gives us a total of 81.5%. All right, couple more. What percents are less than 55? So if we look at 55, this is 3 standard deviations below the mean. This goes to our 68, 95, 99.7 rule. 99.7% of the data is within 3 standard deviations. So from 55 to 85, 3 standard deviations away from the mean, that includes 99.7% of the data. So what we're going to do is take that 99.7% and subtract it from 100, which gives us 0.3%. So 0.3% of the data is less than 55 or greater than 85. So when we cut this in half to get just the percent less than 55, it's 0.15% of the data would be less than 55. What percent are greater than 80? 80 is 2 standard deviations away. This original graph that I gave you, if you add up all of these numbers, it actually adds to 100%. So we need to modify these slightly for our rule. This should be 2.35. And then as we just found out, this was 0.15%. And same thing on the other side. So when we're looking at our example and we're looking at percent greater than 80, we're going to take that 2.35 that's greater than between the 2 and 3 standard deviations plus the 0.15 that's greater than 85, and that will give us that total of 2.5%. The last 2 questions have to do with how many students got a certain score. So the first one we're looking at between 70 and 80. So I cleared out all of those other writings so we can see clearly between 70 and 80 we're looking at 1 and 2 standard deviations above the mean. Our first section, 1 standard deviation above the mean was 34%, plus that second section, that second standard deviation above the mean was 13.5%, for a total of 47.5%. So that's the percentage of students that scored between 70 and 80, but we need to know how many. Give myself a little more room to work here. We're going to take our percent, turn it into a decimal, and multiply by the number of students that took the test. So in the question, it said 2,000 students took this test. So this gives us a total of 950 students scored between 70 and 80. Last question, something similar. How many students scored between 65 and 85? So when we look at our graph again, 65 is 1 standard deviation below the mean. and all the way up to 85. So we have 68% for within 1 standard deviation of the mean. That's second and third standard deviations above the mean. We add 13.5% plus that 2.35%. So this gives us a total of 83.85%. So same process, we're going to convert that to a decimal and multiply it by 2,000 to get the total number of students. And we got 1,677 students. On this one, if you have a graphing calculator, use that to calculate the mean and the standard deviation, and then you can figure out the percent of scores. If you do not have a graphing calculator, do not try this by hand. We'll do it together in class and walk through the calculator options.